Now we're going to go over example 7. It says try it yourself. If you'd like to pause now, try the problem yourself, and then watch it and see how you did. You're welcome to do that. If you want to just watch through and work along with me while I do it, that's fine too. So I did copy the problem here on a separate sheet so I can write, and we'll get started. So when we're doing an integral, we do need to do the antiderivative of this function because it is a product and because there is a function inside of this square root function. We are going to have to use some kind of extra rule. We can't just start right off the bat and just do the antiderivative. So we are going to use u substitution. U substitution means we're going to take out the complicated part of this function. We're going to try to make it simpler. And one of the things as I'm trying to choose what my u will be is I will often choose the thing or the expression underneath the square root or in the parentheses, something like that. And that will help us with our composite function, which is a function inside of another one. So with this one, I'm going to use u equals x cubed minus 2. So all the stuff under the square root. When I look ahead, I know that the derivative of this will end up being in the function with my substitutions in the integral, and the derivative is 3x squared. I see a 3x squared there, so I know that this is a good choice. I'm going to do a little bit of work on my side work here before I start in here. I know I'm going to have to sub out dx, so I like to get that going as well. Dx, our little shortcut we've talked about, is always du divided by the derivative of this, which is 3x squared. Now that my side work is ready for my subbing, I'll go through and work on the problem. So I don't have anything for this yet. So 3x squared just stays. Square root is to the half, and all of that stuff is my u, so it'll be u to the half. And then dx is out, and it's du over 3x squared. This one works out perfect. We have a 3x squared here and a 3x squared in the bottom. They'll cancel out. So I'm left with u to the half du. This is exactly what I'm looking for. These letters match, and there is no product, there's no composite, there's no quotient. It's just a plain variable with an exponent, and I can very easily apply the antiderivative rule to this. So u to the half, I will apply my antiderivative rule, which means add 1, so it'd be 3 halves, divide by 3 halves, plus c. I'm going to do a couple things at once here. I am going to unsubstitute, so x cubed minus 2 is going to go in here, and instead of dividing by 3 halves, I'm going to multiply by 2/3. So that's my divide by 2/3, divide by 3 halves, multiply by 2/3, and then I'll unsubstitute. And that would be my final answer.